Hi everybody, welcome to my metaphysical crystal palace. My name is Angela and I hope you've been watching my previous videos. I think this is the 5th video that I've done on crystals and just talking metaphysically about different subject matters. Tonight I would like to discuss not so much metaphysical matters or anything involving the metaphysical sciences. However, I would like to talk about crystals and optical phenomena that occur and terms that are used to describe these optical phenomena. Well, look, it looks like Romeo feels left out right now. So I might have to pick him up and put him on the couch. I hope you don't mind. I'll introduce you to him. Okay, Romeo, so pick him up. So do you want to meet the audience? Okay. This is the YouTube audience. And here we go. So this is Romeo. And thank you so much for being patient. So Romeo likes to be involved when I'm talking about metaphysical things and about crystals because he just loves crystals. So I'm going to put him here on the couch and hopefully he'll be nice and relaxed. And if he does start to bark, he's going to have to go inside. Okay, so let's get going. We're 2 minutes into the video and you haven't heard anything yet about optical phenomena that occurs with crystals. Anyhow, I want to talk about the terms that are used to describe this different type of optical play that occurs with various forms of crystals. The first term that we'll be discussing is asterisms. Asterisms occurs with Moonstone. And I have some Moonstone right now to show you. Look at that gorgeous Moonstone. So this is Moonstone. You see the blue flash? I also have, let's see, this is Moonstone, where you could see the play of light, but you could really see it on my bracelet. Do I have any other Moonstone handy? I don't think so. But this is a wonderful example of Moonstone, and it's a wonderful example of asterisms. So asterisms is one of the things we're going to discuss. The second is chatoyance, or you could also say the word chatoyancy. Now, chatoyancy occurs especially with Tigereye. So I need to show you some Tigereye, and I hope I have it handy. Do I have the Tigereye? I certainly do. So this is Tigereye. And you could see that. You could see the effect that it gives. You see that sheen? That's chatoyance. And then the other term is opalescent or opalescence. And that occurs with different types, various forms of opals. Pearlescent. That's another term to describe the optical phenomena that occurs with things like pearls and mother of pearl, which I have a wonderful example of a mother of pearl necklace right here that I got from Gemstones. Gemstones is such a wonderful company. And they sell various forms of gemstone necklaces that are healing grade gemstone necklaces. This is mother of pearl. And then iridescent. So iridescence would be, this is what's called a, well, it's, this particular quartz is from Brazil. And this is called fire and ice. Do you see the colors in there? The color play, the rainbow color? That's an example of iridescence. Okay, which is part of the luster. So let's go right into Asterisms. I love that name. Isn't it wonderful? Say it with me. Asterisms. Even Romeo likes that name. Don't you, Romeo? Okay. So, asterisms is an optical phenomena that is produced and exhibited in gemstones such as Moonstone. I already gave you the example. It is the metallic iridescence. Now, you're going to hear that a lot during this video, where the different terms that I described to you and that I mentioned all have a certain marriage together, an interplay. It's the metallic iridescence originating from below the surface of a stone, which occurs when light is reflected between layers of minerals. Now, this is also seen in labradorite. And here we go. I have a gorgeous example of labradorite. This is a labradorite palm stone. By the way, I'd like to mention that I also sell all the crystals that I'm showing you, crystals and jewelry and you name it. If you don't see it, most likely I have it, because I have over 50 different types of crystals, and I sell silver jewelry and with gemstones. It's just beautiful. And I have an Etsy shop, which I haven't put everything on there, but you could find me on, this is the name of my Etsy shop, Apothecary Holistic. Apothecary Holistic on Etsy. So it's etsy.com/shop/holistic. I don't know if it's a slash, but you know what I mean. Apothecary Holistic. Etsy.com/shop/apothecary holistic. That's the name of my shop, Apothecary Holistic. You could also find me on Twitter and Instagram on Ange1NYC. Pinterest, I'm also Ange1NYC, but I think on Pinterest there's spaces in between. So you could find me on Instagram, Ange1NYC, on Twitter, Ange1NYC, and on Pinterest, Ange1NYC. And you know what? Since I'm talking about contacting me, you could also contact me here on YouTube. If you need to also, if you'd like to follow me, go right ahead and follow my Instagram, my Pinterest, and also I have a TikTok. And I'm Big Ange NYC on TikTok. I'm Big Ange NYC. So that's how you could find me there on TikTok. That's T-I-K, TikTok, T-O-K. Okay, TikTok, the clock is going. We're already past 8 minutes. So here is an example of labradorite. That's the metallic iridescence, which originates from below the surface, and it occurs when light is reflected between layers of minerals. Do you see that? Okay, I took lots of notes because I really wanted to share this wonderful information with you. Moonstones' unearthly glow is caused by light scattering between microscopic layers of feldspar. The effect of asterisms, also commonly referred to as Schiller, or Schiller as spelled S-H-I-L-L-E-R, is best described as a milky bluish luster. Now, do you see the blue flash? We call that blue flash moonstone. Or glow, originating from below the surface of the stone. Isn't this fun? The Schiller, and that's spelled S-C-H-I-L-L-E-R. The Schiller appearing to move as the stone is turned, or as the light surface is moved. See as I move it? It gives the impression, and this is the good part, it gives the impression of lunar light floating on water. Does that give the impression of lunar light floating on water? No wonder why I love moonstones so much. Are you kidding? I love You know, my astrology chart, I'm an Aries, that's my sun sign, and my moon sign is in Capricorn, but my rising is Cancer, and that's a water sign. And Cancer, one of the gemstones for Cancer is Moonstone. This has always been one of my favorite. Also my favorite is ruby, and that's a perfect stone for Aries, ruby or garnet. So, we mentioned how the lunar light floating on water, how Moonstone has that Schiller effect, and hence we have the name Moonstone. You see, things happen for a reason. You know that. The reason why this crystal, this stone, was named Moonstone is because it gives the effect of lunar light. There you go. This Schiller effect is most typically produced by adularia. You see, we mentioned the name adularescence. I love that, adularescence. Well, adularia is the derivation of that. Adularescence appears in numerous other gemstones, notably common opal, rose quartz, asteriated, and I have a rose quartz to show you. Now, this is asteriated rose quartz, and asterism is also something that I'm going to talk about. And that's basically where it gives like a star effect. It's very hard to actually see it here because this is a raw crystal. This happens to be asteriated rose quartz. But I'm showing it to you, although it hasn't been cut into a cabochon. And when it is, then you could see it even more. But the reason why I'm showing this to you is because you can, just from the raw form of this crystal, you could see an iridescence. You could see it. You see, there's a play on light, that Schiller effect. You could see it. You see that? All right. So adularescence can also appear in rose quartz. Now, this is rose quartz. I have another example of rose quartz, a larger example, and I don't know where it went. But do you know what? It's not the same, and I'll tell you why. I had it here, but I must have moved it. Because this is a specific form of rose quartz. You could see it has a glassy, you see that? There you go. It has a glassy surface, like a vitreous. That's called vitreous. Doesn't that sound good? Am I teaching you anything? Because really, it's my goal to teach you. I hope I'm not boring you because I don't have a fancy, glitzy, all the bells and whistles type of YouTube video. But I don't do cuts. I don't say, oh, Romeo's barking, cut. Okay, I'll fix it later. Guess what? I don't do that. What you see is what you get. And look at that. Isn't that gorgeous? I want to share with you my collection. Now, I have many of these in stock. So if you're so inclined, just reach out and inquire. So, adularescence, Schiller effect, iridescence, play on light, luster. Do you see how they're all interconnected? Okay. Now, due to inclusions in these stones, inclusions are just another word for different types of deposits of composites of crystal, that each type of crystal is different, has its own unique characteristic. The effect is displayed differently. So you won't have the same adularescence in, for instance, of rose quartz or even the fire and ice quartz that I showed you, as you would have in Moonstone. And I already explained that to you because you see the blue flash. Well, that's totally different. So, as an optical phenomenon, adularescence exists only in the presence of light. Now, that's another thing. It only occurs in the presence of light. And the better the light, the better that you could see it. Now, if we turned all the lights and we were complete pitch black type of environment where we were in a closet with no light and there was no light around us, I think you could still see, because this moonstone, I mean, has such agilurescence and blue flash. I just feel like you could still see it. And you know what? I'm going to test that, but not now, because we're running out of time. I don't want to bore you with half-hour, soliloquies. So let's get moving. So it is a product of the interaction between light and the internal microstructure. Now, remember I said that? See how this fire and ice quartz has an internal microstructure? See, it's not completely clear where you could see straight through. This has a lot of inclusions. Here's another quartz, which is clearer, but look at that. Talk about agilurescence, Schiller effect, play of light, luster, and iridescence. Can you get any better? I mean, seriously, is this not gorgeous? This is also from Brazil. These were quarried out of Brazil. This comes from Brazil. This comes from Brazil. Perhaps even a similar location, wherever the vug is, wherever the caves are, wherever the mining area is. It's just that this one is clearer. This one is a little bit more opaque. But this is a happy stone. Doesn't it make you happy just looking at it? Doesn't that make you happy? It's gorgeous. And it's a double termination, see? Double terminated. That means it has two sides. I'm not going to get into the metaphysical properties and what how to use it and utilize it. I'll do that another time. That's for a whole nother video. For now, we're talking about the different optical illusions and the optical effects of different crystals. Just so that I familiarize you with these terms. And then when you're at a party one day and somebody happens to have a crystal like that and you say they're wearing Moonstone, look at that agilurescence. I mean, the people will just be, it's like mind-blowing. They will be very impressed. Okay. So it's not a property of the mineral itself. It's just a product of the interaction between light and the internal microstructure of the mineral. So if you were in complete darkness, completely void of any kind of light, according to this information, you're not going to see anything. You're not going to see the agilurescence. We have to test that. I'll let you know on another video. The effect is produced by alternating layers of two types at a scale near the wavelength of light. Alternating layers of two types at a scale near the wavelength of light. This leads to light scattering and interference. Oh my God. There you go. Light scattering and interference. Is this too much for you? I'm almost done. Now we're going to talk about asterism. First of all, I love that name. I love the word, and it's spelled A-S-T-E-R-I-S-M. If this was a fully cut cabochon, if I were a gemologist that had the proper equipment where I could clean this up, where I could soften it and file it and make it a cabochon, well, you would see the star effect. Believe me, you would see it, because this is an asteriated rose quartz. Asterism is a name applied to star-shaped luminous area to the phenomenon of gemstones exhibiting a luminous star-like shape when cut on cabochon. Am I impressing you? Well, cabochon is, look, it's simple. Just remember the word cabochon. So cabochon is not faceted. It's more of a soft area. So a cabochon. How could I show you what a cabochon is? So this would be a cabochon because it's not faceted like this. You see this? we're not going to talk about this right now, but this is a Herkimer diamond. Isn't it amazing? That's for a whole nother video, people. But do you see how it's cut? Do you see that? Okay. And do you see how this isn't? Okay. But a cabochon, to explain it to you better, is right here on my moonstone. You see how it's not faceted? Okay. So a cabochon is soft and rounded. These are just tumbled. There's a difference. So this is not a raw form of a crystal, and this is chastolite. It's not a cabochon, because a cabochon is a gemstone which is done by gemologists and used for jewelry. So on cabochon would be each one of these, the moonstone. So they're not in their raw form, but they are cut specifically into cabochon. So if I had a star sapphire, I'm sure you've heard of those. That in a cabochon, in a ring or a necklace or whatever have you. Well, that would exhibit a luminous star-like shape when it's cut in cabochon. Shaped and polished rather than faceted. So remember that. It's not a faceted stone. So if I had on, see, these are faceted because they're cut. The cabochon are softer, just like my moonstone. So you understand, they're rounded, more dome-like. Okay. An asterism is an optical phenomenon displayed by some rubies, sapphires, and other gems like star garnet, star diopside, and star spinel. So, are you following me? We're talking about asteriated crystals and gemstones. So an asterism. So it's enhanced reflective area in the shape of a star on the surface of the cabochon. So if these were all star sapphires, the star would be on the surface of the cabochon. But it's moonstone, so we don't have that. What we have is asterisms. Okay. Star sapphires and rubies get their asterism from the titanium dioxide impurities, otherwise known as rutile, which is present in them. So the little rutilation, have you heard of rutilated quartz? The little black rutilations that are in them? Well, star sapphires and rubies get their asterism from titanium dioxide, which is otherwise known as rutile, present in them. Isn't this informative? See, that's my point. This is why I do these videos. I know it's like they're not fancy. I mean, you get what you get, but you're in my crystal palace and you're with me, Ange, okay? You could call me Ange, you could call me Angie. Mostly everybody calls me Angela, but it's okay. Whatever you want to call me, just don't call me bad names, okay? It's all good. The star effect or asterism is caused by the dense inclusions of the tiny fibers of rutile. So you get that. It's like silk. It's also known as silk within the rutile. The stars are caused by the light reflecting from needle-like inclusions of rutile aligned perpendicular to the rays of the star. Here we go again. Do you hear the word light? We keep using the term light. That means if there was no light, completely devoid of light, say we were on the dark side of the moon, you're not going to be able to see that effect. Again, I'm really going to try this. But even if I were in a very dark enclosure, I wonder if there's still some form of light. I guess you'd really have to be on the dark side of the moon, but I'll let you know. These gemstones may exhibit 4, 6, and sometimes 12 rayed stars, depending on the inclusions, the size of the stone, and the facet. So that means depending upon how the cabochon is cut, it could have more striations, more stars, asteriations than others. And I bet you it's more expensive. The more of the star effect, I bet you it costs more money. Now, diasterisms, such as that seen in a rose quartz, see? Of course, now this isn't a cabochon, but imagine it is the result of light transmitted through the stone. In order to see this effect, the stone must be illuminated from behind. Okay, well, how are we going to do that? We need a, what we need is a, let's see if this will help, because we need a light. I do have a light. I just don't want to blind you with this. It's so bright. I wonder if this is going to work. I think it's too bright. It's way too bright. Just not a good example. Okay. See, I tried. I do have a flashlight on my phone, but I need my phone. Guess what? I'm using my phone to do this video. I told you, no bells and whistles. Although I have a camera that has a very good ability to take video, but I really like doing it with my phone. So I'm gonna ask Bob to get me a flashlight. Just give me a minute, I'll be back. Honey? Okay, so we can't find a flashlight right now because the flashlight needs a battery. So, by now, either you walked away, or if you're still here, thank you. Can you please either like this video if you like it? You could leave me a comment, and can you follow me? I'd appreciate that if you subscribe. Okay. Another time, we'll take the flashlight, I'll show you, and I will tell you if it worked. If I'm in a dark environment, I'll tell you if I could still see some of the asterisms. Okay. So we're moving on. We're going to talk about opalescence, which refers to the optical phenomenon displayed by the mineraloid gemstone opal, which is hydrated silicon dioxide. Opal is hydrated silicon dioxide. I also wanted to show you this. Let's go back to the moonstone. See, this is a moonstone pendant. This is also a blue flash moonstone. It's gorgeous. This is also for sale. You see the asterisms? This is sterling silver. And this is actually fire opal on this quartz. This is an Angel Aura quartz. And see the opal? That's opalescence. Do you see the light, the different light going through there? Okay, see? Do you see it? There you go. Don't look at the quartz part because that's different. I'm talking about the opal that's on the top right there. That's a fire opal. Isn't that gorgeous? Okay. So that's opalescence. So there are 3 notable types of opal, and 1 is called precious, 2 is common opal, and 3 is fire opal. Now, I just showed you the fire opal. I don't have examples of a common opal. I do have a precious opal, but it's put away somewhere, and I don't know, it's like in the vault. You know what I'm saying? So each has different optical effects. Do we have a flashlight? I would like to.
I don't know, but I don't have time.
Yeah, I know. Okay, bye, Ava. That was my daughter. The optical effects seen in various types of opal are a result of refraction. Now look at that word. Okay, think about it. Refraction is part of precious opals and fire opals. That was that play of light that you saw. Look at how gorgeous that is. You see the light? I know I'm not going crazy. I see it. I see like an orangey peach. I see a green. Hold on. What else do I see? You see the green? Ah, look at that. Gorgeous. Or reflection. Reflection is in common opals. Due to the layering, spacing, and size of the myriad microscopic silicon dioxide spheres within the stone, and included water or air in its physical structure. So see, there's water, there's even air in the physical structure. Now, I didn't know that, but it does make sense because it does look like a very similar to Moonstone, and Moonstone has that effect that I mentioned has the effect of lunar light on water? There you go. When the size and spacing of the silica spheres are relatively small, refracted blue-green colors are prevalent. When relatively larger, refracted yellow, orange, red colors are seen. And when larger yet, reflection yields a milky, hazy sheen. Well, you know what? I saw both of them. I saw the blue-green color, and I also saw the yellow-orangey, a little bit of the red. Just a little bit, but you could see it, especially the way I'm looking at it right now, which I don't know if you could see. It all depends on the way the light is. You see that? Look at that. Well, you could see all of it. Well, this is gorgeous. It's also for sale. So it's Angel Aura Quartz. See that? And sterling silver. Okay. We're getting there. I don't want to keep you much longer. So precious opal, the general definition of opalescent is a milky iridescence. Here you have the word again. How you see all the words, they're intermingled and they're married together. Iridescence, opalescence, agilurescence, displayed by an opal, which describes the visual effect of precious opal very well. And opalescence is commonly used in lay terms as a synonym for iridescence. So iridescence and opalescence are hand in hand. And in contrast, a common opal does not display an iridescence, but often exhibits a hazy sheen of light from within the stone, like a milky haze. The phenomenon that gemologists define strictly as opalescence. This is a milky sheen displayed by opal in the form of agilurescence. There we go again. I'm hearing the same words over and over and over again. Fire opal is a relatively transparent gemstone with a vivid yellow, orange, red, we saw all that, and rarely displays iridescence, but it has vivid colors within it. Rarely displays iridescence. Rarely displays it, but all those colors are there. In optics, a dichrotic material is either one which causes visible light to be split up into distinct beams of different wavelengths or colors, not to be confused with dispersion. This is more scientific. I don't want to bore you, but imagine the dichrotic material showing the light. It's split up into different beams of light, not to be confused with dispersion, which the light is dispersed instead of split up. So luster, we have the word luster with chatoyancy, and here we go with our chatoyant. Look at that, with our chatoyant Tigereye. See the chatoyancy? All right, that side is darker. It's kind of hard to see, but you can see it on the side. Is the display of luminous bands which appear to move as the specimen is rotated. Chatoyancy, Tigereye. Luster is the way light interacts with the surface of a crystal, rock, or mineral. So, luster is Latin for lux, L-U-X, meaning light. Luster generally implies radiance, that's one. Gloss, that's two, this is very glossy. Or brilliance. Range of terms to describe luster would be earthy, greasy, silky, vitreous, which is glassy, this is vitreous. But this, I feel like it's more greasy and silky, because that's how it feels to me. So those are all the different terms that describe luster. Tigereye has chatoyance, chatoyancy. Visual effect can be likened to the sheen of a spool of silk, a luminous streak of reflective light due to rutile fiber. See, there's rutile in Tigereye as well. You will see this effect in Cabochon, on Cabochon, not faceted cut stone. So this is more like a Cabochon. It's just a tumbled stone. It's not a faceted cut. Opalescent stones, scattered light, milky opals, iridescence like that of an opal. So we left the chatoyancy and now we're into opalescence. I'm almost done. So we have mother of pearl, which I'm going to put on right now because I love this mother of pearl. Abalone. Abalone is like a shell. So that's kind of another example of an opalescent stone. Now look at that, isn't it gorgeous? It's just beautiful. Scattered light. It's iridescent. It's very iridescent. And pearlescent in color. So it's pearl-like. So this is mother of pearl, and it shows a pearlescence to it. So we have covered agilurescence, chatoyance, opalescence, pearlescence, iridescence, and luster. We've basically talked about a lot of things, and it's 35 minutes. So I'm going to let you guys go, and I wish you all a wonderful, wonderful holiday season, because of course we are now in the holiday season. Today is December 7th of the year 2012, and I wish you all a wonderful holiday, and enjoy the rest of the evening. It's a Saturday, so get going with your Saturday night fun. And I hope you enjoyed everything, and I'm going to leave you with this gorgeous double terminated fire and ice quartz crystal from Brazil. And I'm signing off. And don't forget, if you really like the information that I discussed this evening, I hope you subscribe to my channel, like my video, and please go and visit my other videos, because I talk about other different subject matters with crystals and talk about Mercury in retrograde and all kinds of different things. And I will be doing more videos, so then you get to see my future videos as well. Thank you so much. Have a great evening. Bye. Namaste.